Nobody looks particularly hungover this morning. That's quite impressive. Who had a really late night last night? You can own up, yeah? Good work. So I hope I'm not going to put you to sleep if you've got a hangover. You should be okay. This is Maximising Performance in Zend Framework 2. My name is Gary Hockin. I'm a consultant at Rove and also part-time CTO of a streaming video company. I'm a Zend Framework 2 contributor, Zend Framework 1 contributor. I'm also the docs maintainer for Zend Framework 1 and Zend Framework 2. Don't hate me too much for that, but I'm only one man, that's all I can say. We do acknowledge there's a problem, and we're trying to slowly get through it. Yeah, I'm also a YOLO certified engineer, for anyone who knows what that is. That's pretty cool. I'm GH on IRC, so please come and find me in IRC if you have any questions or just want to catch up after the talk. Always more than welcome. I'm at GH on Twitter. I'm actually a Zend Framework 2 certified engineer, but I'm not supposed to tell anyone that till the 3rd of March when the results get posted. So for the sake of the video, it's the 4th of March today. Thank you. So let's get on with what this talk is going to cover. There's been some kind of misconceptions. I don't know if anyone went to the Scale in Symphony talk yesterday. Did anyone attend that talk? So I guess it's pretty much the same message as was given in the early slides of that talk. There's some misconceptions over that full-stack frameworks are not performant. You know, there's benchmarks and they're not performant. And yeah, hello world benchmarks, Silex and Slim benchmark much better than Zend Framework 2 and Symfony 2. But of course they do, because they don't give you the benefits that a full-stack framework give you. Now, I personally believe in a production environment that Zend Framework 2 is significantly faster than Zend Framework 1 in an enterprise environment, personally. That's from personal experience. We've got a like-for-like application that we ported across from Zend Framework 1 to Zend Framework 2, and we saw somewhere in the region of 25% increase in performance. So it's not actually as bad as is perceived out of the box. But that said, there are some hidden and kind of under-documented features that you can use to significantly increase your performance in Zend Framework 2. So we're going to introduce the concept of performance. We're going to introduce the tools you need to monitor and report on your performance. And we're going to show you some tips and tricks and known performance increase techniques to help you increase the performance in your Zend Framework 2 app. We do dive into some code. You know, there's benchmarking. I am going to give a quick introduction to profiling and benchmarking techniques. So if you already know that, it's only sort of 5 to 10 minutes, so just bear with me while I run through that. And if this isn't what you expected, then I apologize. You can leave, that's fine. Well, you're still here. Excellent. So that means that I guess most of you guys are interested in performance improvements in Zend Framework 2, which helps me. So let's start with a question. How many people use Zend Framework 2 in production in the room? Excellent. Superb. That's really encouraging. So all of you should get some benefit, I hope, at some point in this talk. How many people, have played around with Zend Framework 2 but don't use it in production? Yeah, a few. And how many people don't use Zend Framework 2 and never even understand how it works? Oh. Well, I hope this helps you to actually get some excitement for Zend Framework 2. That's all I can say. Yeah. So the first introduction is into the tools that we use. So the first thing that we need to do before we can apply any performance improvements is to understand how our application is performing at the baseline before we've made any tweaks. And to do that, I use a tool called Siege. There's AB, Apache Benchmark, that does largely the same job and gets bundled with Apache. So if you've got Apache installed on your dev machine, you probably have that tool already available to you. And basically all Siege does is sends a known number of connections, sends a known number of concurrent connections to your server for a known quantity of time, and then reports how those responses performed. So it literally just says, send 10 concurrent connections for 10 minutes in benchmark mode, so send them as quickly as you can, and then tell me what happened. Installing it is really, really easy. I mean, basically there's packages for Yum, apt, brew, Windows, I don't know. You're on your own. You'll have to kind of Google Siege on Windows or something. I don't know. Yes, I probably could work it out, but I don't really want to. But yeah, it's really, really simple to install, and it's equally as simple to use. So literally all we're doing here is saying, please siege my server, 10 concurrent connections, 1 minute. -B is really important because that says, please use benchmark mode. Benchmark mode means send the connections as fast as you physically can. Out of the box, Siege will run where it will try and kind of emulate real-life traffic, so it'll leave a random gap between requests of 1 to 3 seconds by default. So out of the box, it tries to kind of emulate real user experience. But obviously, for these purposes, we want to know exactly what's going on when we bombard the server as fast as we possibly can. And then you'll see that all these requests will be sent. And then once you've completed it, oh, that's not aspect ratioed well. Once you've completed it, you'll see something like this. So this is telling you the statistics about how many requests were sent, how many came back successfully, how long it took. The pertinent piece of information here, the first thing I always look at are those two stats, because that's telling you whether there's any problems with the actual code you're running. You want 100% availability and 0 failed transactions. Obviously. You don't want to be benchmarking something where there's been errors in the script you're running. So this is a really useful tool actually for using in a kind of staging environment. I even use this tool in a live environment with low concurrency, let me be perfectly honest. But it's really useful if you've got a load-balanced environment and you're seeing kind of intermittent problems and you're like, is there a problem here somewhere? I can't work it out. I've got 6 servers. Have we got a bad deploy somewhere? This is a great tool for finding out if you have problems on one of your webheads. You do have to turn off sticky load balancing, otherwise it just doesn't help, as I found out to my cost. But for the sake of this talk, the most important pieces of information we'll be looking at are the response time and the transaction rate. So the response time is the average time it took for the request to return the response. And the transaction rate is how many transactions, how many request-response transactions can my server currently handle per second. So it's a really interesting metric. Not really useful in the real world, but for benchmarking purposes, it's a really, really good metric. It's kind of what we'll be using to measure performance improvements throughout this talk. So does anyone currently benchmark and use these tools? Yeah, a few people? Okay, so there's some information here. That's good. And that's our baseline. So that's what we'll be using, not that particular one, but we'll talk through improving the skeleton app, and we'll be using transactions per second as a measure of improvement throughout the talk. So the next thing you need to do then is to profile your application. We've recorded how our application is performing. Now we need to understand where the bottlenecks in our application are. Where's the bottlenecks in the PHP code? And to do that, we use, I should really stop looking at, sorry, that's really going to hurt my neck. To do that, we use a piece of software called Xdebug. There's also XHprof, which is a smaller, more neat piece of code, which is written by Facebook. I'm going to actually contradict what the speaker said yesterday. You should never, ever install Xdebug in production. Please don't do that. Even if it's turned off, please don't do that. XHprof, on the other hand, can be installed in production, so can be used to profile live production code. And it's kind of neat. We kind of use XHprof in production. We just roll a dice on every request, and 1 in 100, we'll profile it. Or we can knock that up a bit if we're experiencing problems. Because you can actually call the profiling for XHprof from within your PHP code. Whereas Xdebug, it either is debugging or it isn't debugging. You can't just profile small parts of your application. So XHprof is definitely something to look at after this talk. I'm going to be using Xdebug. Everybody should be using Xdebug anyway. Is anyone not using Xdebug? I won't embarrass you, it's fine. Yeah, Xdebug also, as well as giving profiling, gives you step debugging and stack traces when you have exceptions or errors in your code, so it's really useful. If you've already got this installed in your dev machine, you're halfway there. Yeah, installing it, I'm not going to really run through that, but there's umpteen ways to install Xdebug. It used to be really difficult to install, but it's much easier now. Thanks, Derek. You just need to enable it in your PHP-INI. So the pertinent information here is, looks counterintuitive because we're saying enable equals 0. Well, we don't want to actually profile every single request. It can profile every request that comes in. But if we use this trigger, then it means that we can pass this Xdebug profile get parameter, query string parameter, and it'll only profile the requests that you pass that parameter to, which is much more useful in my opinion. And the other piece of software we're using is WebGrind. WebGrind is just a friendly way of displaying the profile information. So the profile information is just this huge file that nobody's going to be able to read with their own eyes. So you just need a piece of software to interpret that so that you can read it. There's plenty of OS-specific kind of desktop applications that do a slightly better job than WebGrind, but WebGrind's just really easy to install, and it gives me the information that I need. If you need to deep dive further into your profiles, then yeah, just look up, there's Linux and Mac, and I think there's even Windows applications that will let you deep dive into the code. And WebGrind just looks a bit like that. So in this example, you know, we've ordered by total self-cost, so we're ordering by the most expensive functions, the most expensive processes first, which is obviously what you want, because you want to pick off the things that are most expensive. We'll come back into that in more detail later. And then you just need to you know, once you've interpreted what is causing slowdown in your application, you just need to change it. You just need to make the code changes to think, oh, right, I can understand why there's a bottleneck there. You know, let's cache this, let's do that, let's reduce that loop, and then push those to your stage environment. And then, of course, you want to siege again, because you want to confirm that the changes that you suspect have been causing the slowness have actually been fixed. You know, this isn't and should never be guesswork. You really want to vindicate every change has given you a performance increase. Particularly, sometimes you'll be doing a trade-off between performance and maintenance. You'll be refactoring this little area so that, you know, it's more performant, but you may be losing a bit of maintenance. Maintainability, I should say, rather than maintenance. So making sure you vindicate each change is really, really important. Yeah, that's not kind of worthless. So I guess, yeah, I'm calling this the cycle of hope, where you siege, you profile, and then you make your code changes, and then you carry on. Davey Shafiq, who's actually speaking downstairs, has a much better slide than me, so I stole it blatantly from him. And he calls it the performance loop. You won't be seeing him using this slide, because he's actually talking right now above us, so there we go. He can't know that I'm using it, so it's all good. So, are there any questions regarding profiling, benchmarking? Is that all kind of straightforward? It's good news. Oh, I forgot to start my timer. Never mind. Oh, how many? Okay, 15 minutes, not bad.
Do you know what pages to benchmark in the first place? You know you're saying you have the address bar you put in the query
Yep.
string to know
Yep.
what to profile. How do you necessarily know what to profile?
It's an excellent question. So the question is, how do you know which pages to profile in the first place? It may be that only certain requests are not very performant. You know, maybe your home page is great, but there's the odd page that's causing you problems. That's where turning the enable to 1 is helpful.
On production?
No, not,
You wouldn't have anyway.
not in production. I mean, if you're looking to do this in production, this is where XHProf comes in really, really useful. I mean, we genuinely, even when we feel like we don't have performance problems, we run XHProf with 1 in 1,000 profiling, for example. And once I generally knock that configuration value down once we launch a new version of our software, because I'm interested in looking at the profiles once we've released a new version and to find out if, you know, are there any other more hidden bottlenecks. Yeah, there is a kind of dark art to understanding which part. Generally, it's because users are moaning that, you know, yeah, everything works fine, but when I go to the news page, it takes 3 seconds for the page to render or something. But yeah, it can be tricky to actually find out which parts are causing you problems. I'm really talking about, sorry, I'll come to you. In this talk, I'm really talking about specifics of overall improvement of every page in Zend Framework 2. And maybe some of these techniques will, you know, may help you to understand where the bottlenecks are. Sorry, was there a question?
Yeah. Can I have you use the mic?
Oh, I'm really sorry. I do tend to take questions all the way through the talk. So
when we've profiled our ZF2 application, we're using an ORM doctrine.
Yeah.
And I'd say a large majority of the results are actually doctrine.
Yeah.
So in terms of the code that we've actually written, obviously a lot of it will use the ORM, but they tend to be at the top. Obviously it's talking to a database, which is always going to be slower.
Yeah.
But in terms of us performing our own code, it's very much, in comparison, a lot lower down the list.
Yeah, it would be. So the question is that generally the doctrine ORM is in use, and that tends to be at the top of the list of performance hogs. It's really common. You'll hear me speaking about performance over maintainability a lot through this talk. Some optimizations will give you, much more performance, but will mean further down the road you get more maintenance headaches. And then that's the question is of you guys to decide whether, at this point, is throwing more money at bigger servers or faster servers more important than being able to maintain your code further down the line. I would suggest it's not, because CPU hours are a lot cheaper than man hours. So, yeah, that can be tricky. I mean, specifically, this talk is talking about how to make sure that the Zend Framework 2 parts aren't the ones that are at the top of your performance hog. But I can certainly, if you find me after, I can put you in touch with somebody who can help you out with doctrine performance. Without that's that's not a problem. Unfortunately, outside my expertise. But yeah, shoot.
Specifically for web applications, is there a way of with Siege going to concurrent pages? Say, first of all, log a user in.
Yes. Yeah. So the question is there a way that you can use Siege to more properly replicate real user activity rather than just bombarding one page? I guess that covers it. So you can tell Siege, you can set up a text file and tell Siege to visit these pages in order. And what you can also tell Siege to send post data to the first page. And you can also tell Siege to use cookies, so if you need to maintain a session. That's really, I found it to be really, really troublesome, if I'm honest, personally. Maybe it's just that I'm kind of not really interested or very good at that kind of, recreating human activity in the command line. I tend to get bored and go, it's not working, forget it. But yeah, you can definitely do that with Siege. It's possible. So quickly, we're going to cover a few points in Zend Framework 2. Hopefully, because you've all said, most of you have said you've at least used Zend Framework 2, you understand these concepts, they make sense to you on that slide. We'll cover them briefly when we get there anyway. So this is a really, really, really important point. The whole of the benchmarking and the profiling that is being done in this entire talk is only on the Zend Framework 2 skeleton application. So I'm literally only profiling the Hello World Zend Framework 2 skeleton application. I've done it to try and make it a little bit easier and to try and help to show the bottlenecks in the framework itself at its simplest level. But you should always realize that in real-world enterprise applications, the figures I'm showing here will be the same because I'm showing the problems in microseconds. So those problems will still exist in your application. However, they may not be a very high percentage. You may have userland code. You may have a doctrine ORM that's also contributing to performance problems. So while I've kind of used the simplest possible method to try and make it quick and easy for everyone to understand, some of these figures need to be kind of taken away and thought about if you're looking to do this in your own application. You almost certainly will not see the performance increase for some of these techniques in your applications, as I'm going to show here. I've also kind of tried to exaggerate some of the problems just to make sure, the point is hammered home, but I'll tell you where I've done that at each point. So this is the first benchmark I did on the Zend Framework 2 skeleton application. It was just sieged on this MacBook right here. It's 100% available. There's no failures. 33.24 transactions per second, 0.3 response time. Not particularly good. This is just an out-of-the-box skeleton application. So then we profile. We look at the profiling, and there's something that if you can you see that at the back? Is there anyone in the other room? No. Excellent, that's even better. Otherwise my laser pointer doesn't really make a lot of sense. So Can you see that at the back? Can you read that okay? Okay, cool. So the first thing to notice here is that the top of the list is composer autoload, class loader, load file, composer autoloader, class loader, find file. So 32.6% of this skeleton application is being taken up by composer loading classes, and nearly 8% is being taken up by the autoloader finding files on the operating system. That's 40% of your application response time is being used just getting the PHP files from the disk into the memory. 40%. I mean, that's pretty crazy. But luckily, it's really, really easy to fix. So this was my development machine. I don't have an op cache installed. Does anyone here not run production code? Sorry, let's make that easier. That was going to be a full sentence of double negatives. Does anyone here not run an op cache in production? Okay, you should definitely run an op cache in production. It's, I mean, literally, it couldn't be easier to set it up. And even, so literally, you've got APC on PHP 5.5, and you've got opcache on 5.5, which is bundled. And this is what the results are when you enable the opcache. So 10% is now being used to load the classes, and more is actually being used to find the files. But hey, we've still got a transaction rate that's gone through the roof. So an op cache is obviously, I'm preaching to the converted, everyone but a couple of people are using an op cache. You've already solved one of the biggest problems, one of the biggest headaches that Zend Framework 2 has. But that's not really good enough. It's still nearly 20%, over 20% of this response is being taken up by just getting the PHP files into memory. Before that, even though they're using op cache codes now, it's still taking a ton of time to find it. I have no idea why that is when you've got an op cache, because these files should already be in memory. And I've asked tons of people who are much more intelligent than me, much brighter than me, and know exactly what goes on in the fiddly internals bit that I don't really care about. And nobody can really answer it. But luckily, there is a really, really easy solution. Because there's a module out there that you can literally drop into your Zend Framework 2 application, and it's called, if I can pronounce this, EDP Superluminal. And that might make sense to anyone who knows what superluminal is. Apparently, it's like faster than the speed of light or something. But it just literally looks at your dependency graph, which classes this request is dependent on, and then all it does is combines them into one file. It kind of minifies them and just combines them into one file. So instead of touching the disk to find 30 files, it literally just loads one file in. It's written by this guy, Evan Curry, who wrote the Zend Framework 2 module manager, so he obviously knows what he's talking about when it comes to these things. He's also my boss at Rove, so I have to say nice things. But it's so simple to use. It really is, ultra simple. You literally clone it into your vendor folder, because for some reason he hasn't put it on packages yet. I'll kick him about that when I get back from this conference. You should be able to use Composer for it, but you can't. And then you literally enable it in your application.config, like you would with any module. And then all you need to do is use this query string parameter to generate the cache file on any pages that you think are particularly heavy. We use this in production, and we use this as part of our deployment process. We put the application into maintenance mode. We push the new code all automatically. We enable a config value to say, yes, we're going to allow these cache files to be built. We hit the URLs we want to. We turn off this cache generation, because you don't want your user land users to be able to actually bring your application down by sort of DDoSing you with that. That would be painful. And then everything's good to go. And then just by enabling that module, we've gone to basically insignificant amounts of profile information. 117.52 transactions per second, under 1%. Now you don't have to worry about it. Anytime something gets that low, you're just like, that's as good as it's going to get. Forget about it, move on. So luckily, there's really easy wins to fix autoloading. I guess these autoloading problems are a symptom of kind of the PSR movement, where there's an agreement that we'll put one class per file, and it makes maintenance and interoperability much, much easier, but there is a performance implication, particularly if you're not using opcache. Yeah, question?
Could you wait until I get you a mic, please? Sorry.
I can just repeat the questions. If it's easier.
This class loading problem, wouldn't be possible to solve it by using some composer features, like a class mapping and this sort of thing?
So the question is, would it be easier, would you be able to solve this using Composer's class map generation features? The answer is almost certainly yes. You could improve the performance from, from the 89. You could definitely get an performance improvement by using the Composer's class map generation. Zend Framework 2 also ships with some class map generators, which we'll cover later on. You still would not get as a good a performance boost as this, because you would still need to be touching all those individual files. So what you would see is that the find file value would decrease, because the autoloader doesn't need to look, whoa, where's this file? It'll know, because it just looks it up in the array, the class map array. But you wouldn't really get the load class benefits, because you still have to physically load those files from disk into memory. So while you'd see some improvement, it wouldn't be as remarkable. Okay?
Okay, yeah, but I guess there is a possibility that there is going to be increased memory usage when you use something like this, and you are loading something what maybe is not required.
Could you repeat that?
No, I was just saying if this cache is loading files which are not required, there might be slightly increased memory usage or something.
Yes, that's a really good point. So the point was that obviously you very rarely get like free performance increase, and the trade-off here is you will get slightly more memory usage. For the trade-off is performance for memory. Again, I would say memory is cheap. You can easily run. I mean, we don't run remarkably sized web heads. We're running our Zend Framework 2 app, like 8 gig or something, and memory generally with the Zend Framework 2 app, in my own experience, and this is only my own experience. Memory is the problem. Normally, typically, you're at 30% memory usage for like 0.2% CPU usage. But yeah, you would use slightly more memory, definitely, because the point is that this is one file as well. This isn't one file per request. So what you will do is you will end up loading classes you may not need for every request that you've run this on. That is a point to be made. I personally think it's a really good trade-off. Personally, that's my decision. But yeah, it's something to be aware of. So the next thing is config caching. Excuse me. So I'll just run through this really quickly because it's fairly straightforward. The way that Zend Framework 2 works is, as you will all know, there's like config files everywhere. You've got config files for your application, you've got your auto-loaded config files, you've got a config file per module. Configs are all over the place. And the way that Zend Framework 2 actually manages this is, at runtime, it'll merge all of those configurations into one big, huge Uber config file. It's called the merged config. You may hear people referring to it in blog posts or in IRC or whatever. It just means that those little config files are no good on their own. So in order for the users to be able to find the keys they want, it just gets merged into one huge config and chucked into the service manager. But recursively merging all of those arrays at runtime is actually fairly expensive. And do you really need to be merging those arrays every single request? Does your database credentials change per request? Why are we even doing this? So the solution is that we can cache the configs, we can cache the merged config so that we don't have to do this iterative config merging at every request. Yeah, cache all the things anyway. So anything we can do that, that caches something to stop a process happening is obviously good. So I need to remember. Oh, right, yes, I know. So this is an application I set up which has 100 modules, so 100 config files. Obviously, I've turned off EDP Superluminal just to try and isolate the exact problem that I'm trying to show. And we've got 23.69 transactions per second. This is actually not the Skeleton app. This is a real-world application. And merging the config is taking like 3,000 microseconds. It doesn't sound like much. But then we can enabling the config cache is really, really easy. I mean, it's just this line. It's just these lines. And that's it. I mean, that's caching to disk. You can cache to other places, but just for the sake of the simplest possible example, we're just caching this to disk. And then you think, well, hang on a second. You've just turned on the config cache, and the times are actually slower. What the hell just happened there? And this is a really simple explanation. In the module.config.php for this application, we've got a service manager factory that's a closure. And closures cannot be serialized. Closures that are stored in an array cannot be serialized. So actually, what we've done here is we've turned on config caching. We've got a merged config that's got closures in it, so it can't be serialized, so it can't be cached. So all we've done is we've actually added another overhead, because now the framework has to look in the cache first and go, oh, there's no cache here. OK, I'll do the merge anyway. So we've added an overhead and not actually solved that. When I actually did this slide, which wasn't that long ago, you wouldn't get an error if you did this. Now you do get an error. So if you're running the latest versions of Zend Framework, you wouldn't be able to physically reproduce these figures, because it'll just throw you a fatal, which is either good or bad, depending on how you want to look at it. But yeah, typically you only have this on in production. So I would advise before deployment, turn it, and you're going to turn this on in production, turn it on in staging so you can catch anything like this. But it's really easy. I mean, you guys should all know that it's really easy to move that to the module.php. So there's two places you can define services for the service manager, in the module.config.php and in the module.php. So we've just moved that. I mean, I personally love to use these closures as service factories. Does anyone here use this method? Everybody should be, right? Yeah? Not everyone, wow. So yeah, I guess it's because I'm lazy and I really can't be bothered to write a whole new class for a factory. I'll just chuck it in a closure. Who cares?
We are using it with mobile now.
Yes. So this is the easy version. The actual correct version is to use proper service factories for each of your classes. But who wants to do that? Life's too short. So we literally just move that function, and then we see the improvement we're expecting. Yeah, kind of underwhelming, these figures, I guess. Yeah, not so good. Not so good. Oh, now I realize why it is, because I didn't use this with 100 modules. I did it with 10 modules. So with 10 modules, we saw a fairly small increase, but we saw an increase. In an enterprise app where you've got, maybe 20 autoload configs, 100 modules, 50 modules, you will see improvement. Absolutely, you will. Routing. So
Can you store that config in like APC cache?
You can. So the question is, could you store that config in an APC cache or memcached or Redis? Yeah, absolutely. You can use any Zend cache container, or you can write your own Zend cache compatible container to cache that. As I say, I just cached it to disk because it literally is one line of code to show in a slide rather than trying to show kind of more complicated code. But yeah, you can cache it to an APC. APC would be ideal because it just wouldn't even serialize it. It would just stick it into the APC cache, the user cache. Routing. So actually, routing in Zend Framework 2 is pretty good, particularly compared to Zend Framework 1. It's actually, pretty cool. It's not the slowest part of your application, but there is a secret to making sure that your routes and your routing is the snappiest it can be. And the secret is not actually that exciting. The ordering of your module, the ordering of your routes, and the ordering of your routes actually make a huge difference to how quickly that route is matched. So I set this up with 5,000 routes. So we've got the home page route here at the top of your route definition, and then there's 5,000 routes under it. Of course, I'm hoping not many people have got 5,000 routes in production applications. It's possible.
Keep it in database.
Yeah, absolutely. Keep it in the database was the comment. Yeah, because that alleviates this first problem, which is parsing all of those roots from an array into a root object is a real problem, which is why this would never run in production. But, I mean, we can pretty much discount this parse root definition because that isn't going to change between the examples. That's going to be a constant. So, yeah, while it's kind of mortifying, we can just put a line through it because that problem will exist through all the examples I'm going to give you. So really what we're looking at is matching the root, 267,000 microseconds. Transaction rate, obviously terrible because I'm parsing an array into an object 5,000 times every request. But it kind of highlights the problem. Oh, yes, that's the slide I wanted. So then all we do here is we literally take the home page root definition and put it at the bottom of the config file. So there's 5,000 roots, and then the home page root is at the bottom. And the transaction rate, goes up slightly, but the pertinent information here is the matching actually goes down to 135 microseconds. The reason the transaction rate hasn't gone up very much is because we're still parsing all those arrays into root objects, which, as I say, it's a constant. But imagine how big this would be if we didn't have that problem, if we were, matching the root, loading in the root objects from a different source. We're still parsing the 5,000 roots per request. That's the pertinent information. But by moving the root from the top of the definition to the bottom of the definition, it matches a hell of a lot quicker. And that's just simply because it's a last in, first out. The root matcher actually looks at the last thing defined. If it's got a match, it'll just terminate early. It won't iterate through all the roots to try and find another match. It'll just say, oh, I found a match, great. So the ordering of your most popular roots to the bottom of the root definition is really a good way to improve performance in those pages. I personally feel in production, since we did this, I didn't benchmark, but I felt like our homepage became immediately slightly more snappier. I was only using Chrome's tools to look at the response time. It was about a 10% improvement in the response time in Chrome, but we didn't do this scientifically, which I wish I had if I'd known I was going to give this talk. But it definitely helps. The other thing to remember is that module ordering also counts here. Because if you've got the home or the most popular roots at the bottom of your module, at the bottom of your root definitions of the module that's loaded first, then all the other roots are going to come under it. So you need to make sure that the module that's presenting the most popular roots is at the bottom of your application.config.php. Sometimes that's not always feasible. If you've got things overwriting other things and you need module ordering to be where it is, then you may want to consider just having a roots module that just presents roots. But yeah, module ordering does actually make a difference here. Any questions? Cool. So the next thing is the view template map. So we briefly touched on template maps and maps in general earlier on. The view template map, literally it just says, when you want to load this view file, this is the file to use. Because if you don't have a view template map, then the framework needs to look at all the modules that present view folders and look in each of those view folders to try and find the view file that it needs to load into the view renderer. So that is, there's a significant amount of overhead there. This is, again, I've set up an application with 1,000 template directories defined. Not really feasible in the real world, but you can imagine that if you've got, I know for a fact that some of the popular modules like ZFC user will present a view directory. Your own modules, some of them will have present view directories, some of them won't, I would imagine. But, it's feasible for you to have 20, 30, 50 view directories. And you can see that actually resolving the file takes a ton of time. And then literally all we do is we tell the view renderer where you actually can find these the view templates. So this should be familiar to anyone who uses modules to present view files. You're actually saying, yeah, I present view files, and they're from this directory. That's not the right code. Oh, okay, yeah. So all you need to do then is to actually add a template map. So to say, when I want layout, use this. When I want application index, use this. And it means that it doesn't have to go into each directory and try and physically find the file. And you actually get a nice performance boost just from doing this template map. So yeah, this is kind of a theme. That does sound like a ton of work. Who wants to actually, go into an array and write down all of the paths to their view files? Yeah, you can do it. There's a generator built into Zend Framework too. So you can generate these view template map files by using the command line template map generator. And then just say, for your template map, just include the map file that was created by that tool. Again, you can build this into your deployment process. There's no real reason not to. You can definitely enable this process as part of your build so that you know that in production you always have these template maps. It's an easy win for me. It's an easy thing to build into your deployment process for not an insignificant performance increase. Any time that's spent stopping the framework from trying to locate files, which as you may now guess is a pattern in this talk, is time you can easily save. So there's also a few best practices you can use to eke some extra performance out. Obviously, don't use closures in module.config.php. We've already covered the reason why. Yeah, it's not a great practice. You should know by now. The other thing is, think about how much you're using the event manager and where you're using the event manager. The event manager is incredibly expensive. It's because internally in the actual code of the event manager, it uses an event stack, and that event stack is cloned all over the place because it needs to be modified, but the original events need to be kept. So it's in the back end, it's cloned a ton of times, which makes the performance severely degrade. This is just a really quick example where we've triggered exactly the same amount of code here, but we've triggered, the first example, we triggered 100 events that did the code once each. And the second example, we've triggered 2 events that did the code 50 times each. And you can see straight away there's a massive, nearly 50% difference. This is a really, really tricky thing to talk about because, as I mentioned earlier on, the event manager is a really, really, really good design pattern for maintainability, for grouping of code, for general best practices. So this is a really big question of where is performance here more important than maintainability. This is a really difficult one. Typically, I tend to kind of ask myself 3 times before I put it in the event manager. Is this the right place for it? Is it really the right place? Okay, yeah, it is the right place. I'll put it in there. I see a lot of code where people, for example, will use the event manager to set up services. So they'll just trigger an event before the dispatch process that sets a few sane defaults in a service they want to use later. That's a good example of where you will definitely be impacting performance, and you could be doing that in a service factory or somewhere else in your application that will definitely give you a performance boost. If you're doing that a lot, moving those things out of events will really help. Yeah, I guess I don't really need to run over this too much because a number of other talks this conference have gone through cache-in. Did anyone go to Eli's talk yesterday on cache-in? So, I mean, yeah, pretty much he covered this. It's realistically, do you need to be hitting expensive storage? Zend Framework 2 has Zend Cache, which, is Zend Cache storage interface. Brilliant. It'll help you to connect to your cache. That's not really the most performant way to connect to your caches, which is kind of poor. You're probably better off using the native libraries that ship with whatever cache you're using. I don't particularly feel like adding the overhead of a wrapper is kind of sensible, particularly a wrapper that's as imperformant as this one. I'm not saying don't use Zend cache, but yeah, don't use Zend cache, I guess. It's not, yeah. I mean, if you use Redis, you've got Predis library. If you use Memcached, I'm sure there's really good libraries that exist that you don't need the benefit of a wrapper for this kind of thing. I mean, one of the things it does do nicely is it handles the time to live, but it does it by adding extra cache items. It doesn't use the native methods of the cache that you're actually using. Like Memcached already has a time to live built into it, so you don't need to use Zend's implementation of that. But yeah, definitely caching. To be honest, the question about the doctrine ORM earlier, and your caching is the best answer to these performance problems. It's the first place to look. As I said, this talk is largely about helping you to understand where the performance bottlenecks are in the framework itself. Almost certainly, you're going to be able to make your application feel snappier with some of these tips, but realistically, the expensive storage calls are where you need to look first. So here's a bonus one for you. How many people run a production website without a fav icon? Oh, one person. And you should definitely know better. So, how many people run a production website without all of those stupid Apple icons that iOS devices ask for? Yeah? Okay, a few more. Really? Yeah, I guess Zoidberg there sums up my shock, because you're using Zend Framework too, or you're using Symfony too, or you're using any framework that relies on URL rewriting. So every request that would generate a 404 is actually bootstrapping your entire framework. If you think about it, if a file doesn't exist on the file system, the whole nature and point of URL rewriting is to say, oh, we don't have this on the file system, the framework needs to handle this. And then the framework will look for a root. And the framework will look for a root, and they'll say, oh, there's no root, 404. And bear in mind that if you have no fav icon, particularly, every single request that your users are making, they're making 2 requests to your framework. Because browsers are stupid. They'll continue to ask for the same fav icon over and over again if it doesn't have one. If it has one, it'll cache it. It's fine. But if it doesn't have one, it continues to ask with every request. And the Apple icons are the same. The Apple iPhone things that you weirdly get asked for when people are looking at things on iPhones and iPads, they'll continue to ask for those things. And there's other files that will be asked for that will be resulting in a 404 that will be resulting in your whole stack being used. Robots.txt, okay, Google, cross-domain XML. Google will be hitting your website fairly often I hope Google is hitting your website fairly often, and other spiders, because you obviously want that to be happening. Now, even if you just have a robots.txt that's an allow, it's going to help because it's not going to result in your framework being dispatched every time the Googlebot comes along. So, yeah, go for it. Yeah, no, please do.
Just about the static assets. If that just does a match on the roots, pass off your text files, GIF, XML,
yes.
JS, CSS.
Yeah.
Then your 404s won't trigger your dispatch.
So it's a good point. The point there was that you can set this up in your web server so that it doesn't dispatch these .ico files or whatever to the framework. You can set it up so your URL rewriting will not try and pass those through. It's a good point, and you can do it that way. I mean, probably as a lazy man, I would probably just want to add the files into the assets, the right place in the public directory. But yes, you can set up your web server to alleviate this problem. It surprisingly does exist a ton in the wild. you know, people don't kind of understand the problem, and therefore it is a real problem in the real world. So it's just, yeah, how you solve it, completely up to you guys, but just to be aware that that is a real problem. You can immediately take some load off your framework by solving the problem however you think is fit. So just, yeah, a quick summary. I mean, use opcache. You should take one thing away from the conference is if you don't use opcache, use an opcache, please. Cache everything you can. Cache all the things you can. Even caching them to disk makes a big difference. Cache your config, cache your template maps, cache your expensive storage calls. You know, you're going to get real good benefit and quick, easy wins there. Use EDP superluminal. Did I say that right again? Superluminal. Yes, thank you. I personally use it in production. You would definitely want to read through the code and understand how it works before making a decision whether it's right for you. But definitely look at it if you're having performance problems. Personally, I've been using it in production for over a year. I've never had any problems. Yeah, I think it's a really, really quick and easy win. Just think about your root ordering. Moving stuff to the bottom of the root tree makes it match quicker. That can be an easy win if you've got a really root-heavy application. Yeah, think twice. Think twice, I think 3 times. But just have a think about, is the event manager really the right place for this piece of code? Yes is a perfectly acceptable answer. You know, the event manager's there to be used. It's a really, really good design pattern. Yes is a good answer. I can't read that on my screen now, sorry. Oh yeah, have a favicon, as we just covered. Most importantly, you know, use tools to record your progress. If you take one thing away from this talk, it's blindly flailing around, presuming that you're making improvements because the site looks better, snappier, is no good. You know, record how you're doing, profile in a staging environment or on a live environment after every deploy. Understand, have I really impacted performance with this release? Understand what's happening and where it's happening. And those tools are super easy to use. You know, there's not really an excuse. We siege and we profile after every single release. We actually siege on our live platform with low concurrency, just to confirm, you know, are you drinking WKD? Oh no, sorry. It's Powerade. It wasn't. It's okay. But yeah, you know, really understanding how your application is performing is not that difficult. It's really not, genuinely. So any more questions? How are we off for time? Sorry.
Good. 5-10 minutes.
Excellent. Any questions? Surely.
Is there, if you think about the architecture, one way is to sort of take the requests, like so they don't even hit Zend Framework, so using Varnish or something.
Yeah.
Is there a cache module for Zend Framework too that's easy to say for these routes, set these expire headers? Because that would, I think...
So the question is there any tools or modules, for Zend Framework 2 that help you to, like, I'm guessing you're talking about reverse proxies, ESI, and kind of...
Setting the response headers.
Setting the response headers. I don't know of any. The good news is that setting response headers is super simple.
Yeah, but it would be nice if it was configured in a global way, sort of in a cache.
Yeah, it's a really good point. So are there any modules or techniques to be able to set response headers so that Zend Framework 2 plays nicely with like a reverse proxy cache, I guess? Or I don't know of any. I'm willing to guess if you go to modules.zendframework.com, you'll find one. How good that module is I'm not going to be responsible, but I think that's a really good point. And if you're interested in making a module, I'm more than happy to contribute. So, yeah, that's a really good idea. Yeah. Oh shit. Yeah, go for it.
Yeah, Xdebug on production. I don't use it myself because I just assumed it was too heavy. But is there a specific reason you hate it so much?
For me, it comes down to 2 particular points. I've seen tons of people who've left Xdebug on by accident in production. In fact, the guy who was talking about the Symfony yesterday, said the same thing. I left Xdebug on for ages, laughing about it. Well, for me, that's not only a performance problem, that's an attack vector. I don't think that a step debugger has any place on your production server, personally. You know, that, one bum config, one mistake, and somebody could be step debugging through your code. That's kind of scary. Not only do they get to see all the shortcuts you took and all, you know, all the poor code you've got, but they can find any attack vectors they want. So, yeah, I genuinely believe that Xdebug has no place in a production server. It's too risky for me personally. XHProf does a damn good job of profiling in production. It's there. Why, you know, use the right tool. Thanks. Is there?
Hi. Just going back to the question about the response headers on the gentleman at the front.
Yeah.
Are you talking about e-tags and expires?
Yeah, exactly.
Yeah. Have you seen Varnish?
Yeah.
Yeah, we talk. So
more about like the global the way to configure those headers.
So
really simply using the module.
The question was, are there modules to help you use the headers that Varnish needs to understand what to do with your responses? So to set the headers that Varnish needs to use with in a kind of cross, I can imagine what you're talking about, something where you can like define these pages should have these time to live in one place, these routes. But I don't know of a module, but it sounds like a really good project. So, any more? Superb. Okay, we've got one here and then here next. Yeah, shoot.
If the event manager is so slow regenerating the events between the different parts of the library, shouldn't they be using APCU internally?
Yes. So Zend Framework 2 doesn't have a dependency on any particular user and cache. So, and that's a business decision by Zend. And I can tell you why that is. It's because Zend Server doesn't support APCU. And Zend will only ever let the framework run on platforms that Zend Server will support. That's a business decision by Zend. It's out of the contributors' hands. So that's the reason why Zend Framework 2 is targeting PHP 5.3, for example, is because at the time of release, Zend Server only supported PHP 5.3. So we couldn't push we wanted to push to 5.4, but we couldn't. The event manager has been completely rewritten to use features in 5.4, as has the router, by the way. There's been some discussion about Zend Framework 3, which is going to be not a big, massive backwards compatibility break like 1 to 2 was, but it's more things will be rewritten to take advantage of features of 5.4, basically, because Zend Server now supports 5.4. So 3 will be a break and change version, but it won't be like you have to rewrite all your code again. It'll be just tweak this, tweak that. But yeah, the event manager has a massive performance improvement in the rewrite that's been done. So that'll be coming soon. And there's probably be a module for backwards compatibility into Zend Framework 2. Any more? Cool.
Hi, yes. Are there any modules that will give you kind of like an A to F rating on certain areas of your application and make suggestions, like kind of like YSlow or page speed does for your browser to say, like your routing example, you were saying if you put it at the bottom, you give suggestions like that. That's pretty cool.
That's a pretty cool idea. There's no modules I know. So the question was, are there any modules that will give you like a page speed rank of your page? I'm guessing, I don't know how many people use Zend Toolbar, Zend Developer Toolbar, or whatever it's called. So that, as a quick promotion, at Rove we're rewriting the Zend Developer Toolbar to be more helpful, and that is in design stage. So that's a really, really good idea, and I think we'll probably steal that and include it in the new the new toolbar that's coming out.
No problem.
Yeah, are we out of time, or are we? See, this is what I love. Thank you, guys. Yes, absolutely, completely open source. Yeah, everything we do is open source. So, yeah.
Hello. I've seen people fork frameworks before to sort of refactor out inefficiencies they found in a framework. Yeah. What would your approach be if you were using a framework or a library and you found an inefficiency which was there for a good reason, but is actually impacting your specific application? I would submit a pull request with a verbose explanation of why I wanted this pull request. And then failing that, I would fork the individual component and use the patched version. I mean, the great thing about Zend Framework 2 is because it's configuration over magic, replacing individual components is really, really easy. So I would try to explain why you think that the change you've made is better, and then
when people say no and slap you down, like, just do it anyway, I guess.
Okay.
Thank you. Any more?
Did you grab it? You got a mic?
Oh, he's got a mic. Cool.
One of the big performance issues that we had with ZF1 was the forward plugin. I don't know if you have experience with that.
I didn't hear what you said.
Sorry, with ZF1,
yeah.
one of the big performance issues was with the forward plugin.
Forward plugin?
Because it would redispatch, obviously.
Oh, yes,
yeah.
yeah. So
In ZF2, obviously being a lot more modular, what I found is I'm using it a lot more. And that is another bottleneck. So basically what we do, we'd hit a controller action and you would have, obviously, aggregated views built up. Yeah. And having that functionality is fantastic, but it does sort of impact performance in that regard. So do you have any sort of suggestions there as to...
Yeah, that's kind of a technique I try and shy away from for the reason that it's not very performant. In any framework, that kind of architecture will be expensive. Yeah. The answer I'm going to give you is not going to be helpful, but caching is the solution there for me, because I'm guessing that having to dispatch multiple actions, I'm guessing, in single request. Is that what you're referring to?
You obviously... obviously you can...
He's toying with you, it's fine.
Yeah. You can obviously call the other controller actions directly.
Yeah.
But the downside for me is that you won't get the dispatch events.
Yeah,
so
okay.
you won't get the event manager called in.
So you're actually... What the hell was that called in Zend Framework 1? There was a trigger in the channel to say how evil it was. The something stack, the root dispatch... Action stack, thank you. Yeah. Yes. By that man of beer. So... Yeah, I mean, I personally think that's not a great architecture to use. I can understand why people use it, because it does give you like really cool reusability and maintenance, but I'm guessing you can cache the results of those individual dispatches and look in the cache first.
Yeah, I guess you could, but...
I mean, I'm personally, even if you cache in a heavy website for 10 seconds, or even if you're caching for like having so what I would do is I would cache this individual user's information at the output of this for maybe 3 requests, so it doesn't change for 3 refreshes. I'm pretty sure there's lots of places in the application where having stale data for 3 or 4 refreshes ain't so much of a problem. Yeah, cool.
Okay.
We got time for one more, great.
So you get it.
I'm eating into your break, guys, so if you do want to leave, I will not be offended.
Thank you. I don't really have a question, but I want to talk a little bit about Doctrine too, because it was asked earlier.
This is even better, yeah, cool.
The single biggest performance issue I had on a production site that was written with Zend Framework 2 and Doctrine 2 was the default configuration for Doctrine is that it automatically generates hydrators and proxies, which are files on every single request. So
you can cache them though, right?
But what you do is you change the configuration on production to not generate them.
Yeah.
And you submit them via version control. So that's
perfect. So that's on the video too. So anyone who's watching this is like, oh yeah, I wanted that Doctrine question answered. So yeah, that's all we've got time for, guys. Please rate every single talk you see on Joined In. We need the feedback to improve. And in my case, to keep up my constantly high value. So please
thank you very much. Thanks, Gary.
Please do rate everything. Thank you very much.